Hi, I'm Ismail from Unity Alabama. Today, in this video, I will show you how to use uh, program the analog channel in multi channel analog. Okay, so please connect the another one variable. Remember the connect it to 3.3 volt and ground for the voltage, and then for the wiper, connect it to the last pin here, PC3 I think. Okay, so we can confirm it here, connect to PC3, and then so the power into 3.3 volt and to ground. All right, so we go to the project. Okay, before that we need to do some sort like simple calculations, right, based on the to calculate the value for the time sampling, right, time sampling for these two channels in 0 and in 13. Assume that the conversion time for this in 0 require is 10 microsecond, and then for the in 13 is 20 microsecond. So by using the formula, this sampling much more greater than ADC clock multiplied with T conversions minus ADC cycle, like 3 in my notes. Then you can key in the cell. Then from that, in for the resolution of 10 bits of, like, you can select this, right. So the time sampling for the in 0 is 62, and the sampling for the in 13 is 137. All right, so remember the frequency you use is 60 meg. So the PC clock 2, the PC clock P clock 2 or PB2 peripheral clocks must be set to 60. So you set this one to 60, right? Then go to pin out, go to analog ADC, click in 0. So you can see this one change to PA0. Then move down, find out in 13. So you can see that PC33 now become green. Then from that, next we go to the parameter setting. So in the parameter setting first, the common setting is always the mode is independent mode. The second one that we interested with is the clock speed scaler. So clock speed scaler is 8 bit. So divided by 8, 10 bit. And then for data alignment, right alignment, scan conversion we need to enable now because we use 2. But for the continuous, it's disabled, right? Continuous conversion is disabled, discontinuous. These two is being used for DMA, and then end of the conversions section is end of single channel, right? Single channel. Again, because we not use the end of EOC, end of conversion flag at the end of all conversion, just be used in DMA. All right, so that's for the ADC setting. Next, for the regular conversions, number of conversions we need to set to 2 because we have 2 now. Then we change, enter it. If you enter it, then you can see the rank now. We have 2 rank, right? None for the external trigger conversions. Regular conversion allowed by software because we're going to trigger by software, not by timer or others, right? All right. So then we go to rank 1. Okay, rank 1. The it is clock at T sampling is 62, so sure we can set it to 84, and then for rank 2 is 130 something, I think. So right before that, the channel must be set to channel 13, and then cycle is 144, right? 144, because this is 137. Okay, you need to adjust it accordingly, and if you can find the cycle for the clock. Then after that we go to NBIC, enable the interrupt. That's all the setting for the ADC. Now we go to the right. Now we can go to the user tool, right? Asynchronous. This one we just accept the parameters. Right, this is the default parameters for F401. Click NBIC, enable it, and then maybe you need a PA file later on. Set to output. Remember this connections, right? The connection to this is D1, which is connected to PA5 in active low mode, but the bottom one, I mean on the nuclear board, it is set to to active high. So we must set this one to output push pull, this one. All right, that's all. Generate code. Click yes. Okay, then after that minimize it. Okay. Get ready with the driver. So we need the 0.1 and user tick for this example, right? User tick just to make use the statistics idea of the system. So for first of all, expand that include, right? Minimize it. Okay, select circum1, circum2, sorry, .h, user tick, right? And then press Ctrl, move it to the include, copy, accept it, move .c to source, no one source, then open it up, right? First of all, go to the circum1, right? So copy this, the vector. Okay, for transmitting we allow up to 100, 1,000, that's no problem. Number of maximum receive 20, we not receive it in this application, or example. So copy that one, make it become extends here in the main. So put it in the global, right, area. Then go to top, then include profile, control space, double quote, user, tick, enter, double quote, inc, control space, double quote, ser, control space. This comes out there. So first thing first, here we need to, right, this one in the user code begin to, we need to maybe we need to transmit, right? Transmit something. Say transmit double quote /r and /r, right? Multi channel ADC in interrupt mode, right? Double quote semicolon. Then as we're going to use the statistic, so set statistic to 1, we're going to use 1. The only one that we use here is just to trigger the ADC. So you can write down if get statistic 0, each say 500 millisecond, right? 500 millisecond. You can use this if you like, then no warning. Then write down HAL underscore ADC underscore start. We're going to start the ADC. Yeah, this one. Right. So accept the handler ADC1. Right. So after we start or trigger the ADC, then when it is interrupted, then we call the ISR or the callback. Callback functions. So the callback function we get it from SMF4 driver, expand source, then click to open ADC. Then what you need to do is go to Window, Show View, Outline. So we'll outline the codes here or the functions here. So we're looking for the convert conflict callback. You can copy all, but I just recommend you to copy it up to here. Go to main, and then we place it here, right? In the code begin. Oh no, sorry, this I make a mistake. It should be here. Enter. This one should be. No, you can place it there, but better if you place it in the global or VB private variables here. Also, okay, so for this we need to first we need to sample it, right? We need to sample it. So what we can do is write down the okay, so we go to the main. First of all, we need to have the some sort like index, right? Index or IDX, right? int underscore t IDX. So we set it to 0 when it started. Then we need another one, the UINT16, because our data is or signal is 10 bit, right? So we name it as digital value. So we have two, right? We have two here. Next, we type if HAL underscore ADC underscore okay. This one is the first one. What's that? Into space. I forgot it. Actually, okay, I can check in my notes. Alright, get flag, ADC get flag. Sorry. So whole ADC underscore double underscore HAL ADC get flag underscore get. Okay, get flag. Okay, so the handler is what? The handler is the ampersand HADC. Okay, HADC1, comma. Then for the flag is HAL underscore ADC underscore flag. Okay, flag. ADC underscore get. No, so I can't remember it. Okay, ADC flag AOC. ADC flag AOC end of conversions. So each time it is at the end of the conversions. What we do is to sample the value or the data from that. So the first when it scan from 1 and 13, 0, 13, 0, 13. So the first one, so we feed it into ADC, into digital value, IDX. Then we increase it, Then if HAL underscore get value, we have get value, I think here. HAL ADC get ADC. HAL ADC get value. Okay, get value. So we get the value from the handler, right? Okay. Then we will check if that I dx greater than 1, because we have 0 1, we have two rank 0 1 0 1 0 1. Okay, so if that greater than index greater than I think this one better I name it as ADC, right? Index ADC, this one to index ADC. Okay, so here what we can see that the first one we get the value each time it is interrupted. Then the second one, if it is full, when it is full, then we need to rearrange again or reinitialize again index to 0. Then we stop the ADC, right? ADC stop IT because we use IT interrupt HADC1 semicolon. Then after that, then we can do some sort like printing, if because if you want to print it in the main, then you need to use flag, flag, make it become global. But this time now, I just want to print it here. So what you do, just sprint F, right? Sprint F into tx2 buffer. Okay. So we're going to print the first one. We're going to print /n/r. The first one is the value of the in 0. No, entity, right? Entity on the left. Entity. Okay. So entity square bracket, say, and then percent %u, okay, comma, or /d, tab, right? Tab. Then we have entity means analog, means analog, for example. Then okay, sorry, I'm not okay. I use the value directly, and I will multiply it inside the sprintf. So this one is percent 0.2 LF. I'm going to use the what we call the double, right? The double. So I copy this one. You see it, right? Copy. Then after that we place another T, then place it this one. So we change this one to 0, in 0. This one change to n 0, right? Then comma. Then you can write down the first one is digital value open bracket 1, because the rank, the second rank or 2 inside the array is interesting, because there is like a 1 being read. Then next one is digital value. Okay, if this one you can put it here, if you like. Okay, data value, comma, 0, right? 0. So that's for this and this, right? But for this one, the n13, for example, here, just copy this one, right? Place it here. Okay, it should be multiplied with the SR, right? Where SR is defined as the SR is defined as the Bref positive minus Bref negative. Remember, our voltage is before is 13, at 3.3, and Bref negative is 0. So 3.3 over our what's resolution, our resolution is 10 bit. So 2 power of 10 minus 1 is equal to 1023. So when we divide it, right, 3.3 divide with 1023, then we got this the step resolution of this, 0.00322 by 322 or about 3.2 millivolt, right? Just copy that one. So multiply with this one, multiply. But remember, okay, please make this one or change type to, temporary to double. Right? Same with this, the second one. Right? So copy. You can copy this one if you like. I think it is simpler. Comma, place it here. Double, but this one also change to 0, right? Then after we split it, then we can transmit. We can transmit, and everything inside the string. But when you see this one, it become red color, right? Remember, in the previous video, I showed you the floating formattings support is not enabled to. So to enable it, so we go to the project properties, right? Then go to C++ build and setting, then go to the MC setting, then tick these two, apply and close. Then you see it's gold, the red color, gold. So that's all it codes. So again, I repeat it. So when you start, just set the statistic, because each time it is 500 milliseconds, we will trigger the trigger the EDC. So DC runs running share, right? Running share. Whenever it is interrupted, then we will call this function or callback, complete callback, conversion complete callback. Then inside here, first it will copy the value, that the converted value into data value array, data bar array, and then increase the index to the next array. Then if come back again, interrupted again, then the second value will transfer into the array, and in the same time it will increase that index. Remember, this is index ADC. I changed already to name to ADC. So we have two. The first one index 0, the second one index 1. So 0 1 0 1. So it keep increase after transfer, so it become 2. So 2 is greater than 1, then it will reset. So this one become true. When this if become true, then it will reset index ADC to 0 and stop the ADC and stop the interrupt. That means it needs another interruption scheme, trigger again, in the while loop. Then it will print out the value inside the memory. All right, this is the data value. This one reconvert to ADC to analog for the data value 1, which is analog in 13 from in 13. Then PC3, if I'm not mistaken, then this is the value from in 0 or PA0. This is the analog value at PA0. Okay, then we can see it. All right, compile and run. Okay. Okay, you can see it now. It comes out. Okay, I reset. Okay, then you see when I play around with the variable, well, in 13 change. Now if I play around with the right, you can see that one also changed, right? Okay, that's all. Bye bye. If you want some more, come to UniCal BMI. Bye bye.